Welcome back to another CCNArchive. In this video, we are going to watch a single piece of data as you generate it by typing in an URL into your browser, and as it goes through the PC, onto the physical media, through a switch, back onto more physical media, through a router, and then onwards towards a server. We're going to see how each layer is handling the data that it sees and the process of encapsulation and de-encapsulation. Firstly though, let's understand the topology that we're going to be using for this and what we're trying to do. So firstly, we have a PC over here and it has an IP address of 192.168.0.10. It also has a MAC address of AA, which I'll just say A for short. As we go through the device, we are going to be sending a packet from this PC. We are effectively going to request a web page from the server over here, which has the IP address of 10.0.0.10 and the MAC address of FF. So that's the starting process. We are going to request a web page from this PC, from this server over here, and this server is going to send us the web page back. So we are going to watch that flow of traffic as it goes from the PC through the layers of the OSI reference model and how data gets added onto it to be encapsulated so that we end up with these different things from, the data itself to a segment to a packet to a frame onto bitstream. Okay, we're then going to see that entire bitstream arrive at the switch, and we'll look at what the switch does with that information before then sending it onto the router. It'll be received by the router's gig00 interface, which is this one right here in the blue side, which has its own IP address of 192.168.0.1 with a MAC address of BB. We'll see what the router does when it receives that and how it ends up deciding to send it onto this interface, which is interface gig001 with an IP address of 10.0.0.1 and a MAC address of EE before sending it onto the switch. Now again, we're only going to watch the flow of the HTTP traffic, so that web page request, and we're going to see it in this animation. And as I said, we're going to look at it through the layers of the OSI reference model. So what we'll see is as we're going through this, we are going to see the representation of data using a single symbol. So the raw data is going to be symbolized by a 0. Okay, and it's going to be showing in the middle there. As we start to go through that, you'll see how the raw data never changes, but we add more information onto it as we go, and what information is being added where. In short, this is a simplification of what's going on, but it's a very good visual representation and it helps you understand what happens at these layers to give you the idea of what happens in the fraction of a second. So at this stage, we're pretty much ready for the animation itself to just kick in. I've described everything that we're going to do. The only thing to really point out is that what we'll see is this PC out to S in, S out. That is the PC. We're going to watch that traffic build up and it's going to go through the layers until eventually it gets put onto the physical layer, at which point it'll be sent along this physical line here towards the switch. The switch will then receive it on its inbound interface. It will process through those layers and then send it to its outbound interface, at which point it'll go back through the layers and we'll see what happens. The router will then receive it on its inbound interface gig00, process it, and then send it out of gig001. And again, it'll go through these layers. And then finally, it'll be received on the server and it'll go up through these layers one last time. We're going to see how each device handles this ever so slightly differently. So without further ado, strap your seatbelts in, let's go for this. So there's our raw data. So the PC opens a browser application like Chrome or Firefox and enters the server's URL, its web address. The web browser on your PC is now ready to open files presented in a HTML format. And the web browser is ready to exchange data. Now at this point, it's just data. You can see represented as zeros, it's all just data. So the data now moves into the transport layer where interesting stuff starts to happen. At the transport layer, we need to identify what the protocol or the transport protocol in use is. So firstly, we're going to add the source port, and this is going to be a random number, in this case 54321. Then we're going to add the destination port, which is port 80, which is the number that represents HTTP. So we've now added these details. It lets us know that it's HTTP traffic and that that's part of the TCP suite. That data the 0, has now been encapsulated with this information and becomes a segment. So that's what it's called at this transport layer. The segment will now move into the network layer, where, surprise, surprise, it needs to be encapsulated, again, have more data added on. So in this point, we need to identify where we're coming from and where we're going to. So we need to determine, are we going to be local or remote? Are we sending inside the blue or to the yellow? Because there is a router between the PC and the server, it means that delivery will be remote. The servers are demarcation point effectively. At this layer, we use an addressing format called logical addressing, IP version 4 or IP version 6. So we add the source information. 192.168.0.10 is where our packet's coming from, and it's going to 10.0.0.10, the remote destination. Fantastic. So we've added the details. We now know that we're using IP version 4 and that the delivery is a remote delivery because it's going to a different network. That segment has now been encapsulated and turned into what we call a packet. The network layer packet now moves down into the data link layer. At this layer, we need to identify where we're going locally. So within the blue network, where do we need to go to get to the yellow network? So because the server is remote, we need the local help to get there. And this is where we call in the help of our default gateway. So we need to send this to our local router and its default gateway. And we do that using its MAC address. So at this layer, we use the MAC address, but it's its physical address, and it's what we use for local transmissions inside the blue network. We add the source MAC address of AA, and now we're going to add the destination MAC address, and we're going to use BB, our router's local address. Okay, so there we go. We've added the details. It now knows that we're sending the data to the default gateway. So that's how it knows how to get to the router. The packet has now been encapsulated and will be turned into a frame. So that is now our frame at the data link layer. It's called a frame. The frame is now moved into the physical layer, where it will be converted from its frame into binary bits, or bit stream, as we often call it. So that's your ones and zeros. And once it's, this happens whilst it's happening, but it's now going to leave the PC and head towards the switch. So that bit stream now arrives at our switch. And in this instance, it arrives on Fast Ethernet 01 is the interface on the switch. But again, we're not too concerned about that. The switch converts that bit stream back into the frame. So it pulls it back up. What left here is now being seen here. We look at the source MAC address, so we know that it came from the PC. And now we're going to have a look at the destination MAC address, and we can see that it's going to be B. Okay, so the switch has read this frame. So the switch is going to look up something called a MAC address table to determine to see if there is a destination on its or an interface that links to BB, which in this case there is. Fast Ethernet 02, this cable connects to that interface. So the switch is a layer 2 device, which means it doesn't actually need to look any further into any of these details. So it doesn't need to go back into the network layer or anything. It's quite happy to just pass this from the inbound interface to the outbound interface now. So it's already passing it over. Nothing's changed. The frame has simply been read at this stage. So the switch did nothing other than read the frame. We move the frame into the physical layer, where it will once again become bitstream. Converts it into bitstream, sends it along the path, and it should arrive at our router. There they go. Okay, so our router's gig 000 interface receives that bit stream. Like the switch, it's now going to convert that bit stream back into the frame. Okay, so it's then, after it's converted that information back into a frame, it's going to do the same that the switch did. It's going to read the information. So it looks at the source of the MAC address and sees that it came from PCAA. It's now going to look at the destination MAC address. And in this instance, it's going to see BB. Hold on a second. That is the actual MAC address for this router. So what that tells the router is like, this is destined for me. So I should look a bit further into this. So what it's going to do, it's going to de-encapsulate or decapsulate that frame and turn it into a packet so that it can now look at the IP information that is held within the packet section. So it looks at the source IP address, knows that it came from 192.168.0.10. It's going to look at the destination address and find out that it's going to 10.0.0.10. Now, like the switch, it's going to look up a special kind of table. This one's called a root table and is slightly different, but it's going to look for a match for that 10.0.0.0 network that the server is part of, and it can find one in the gig 001 interface. A router is a layer 3 device, so this means that it doesn't need to look any further into the details, and it can pass this now on to the outbound interface. So it's passing it to the gig 001 interface to be sent outbound. Now, something needs to change here because we've discarded the segment information, sorry, the frame information. We don't have that anymore. It made its AA to BB destination. So we need to rewrite the frame. So the packet has stayed the same, but the frame needs to be rewritten now. We need to re-encapsulate it. So unlike the switch, the router has changed these details and we need to add new information in. The reason why, AA to BB, that has been completed and that information now discarded. So we add the new source MAC address, which is going to be the router's MAC address of EE. We then add the new destination MAC address, which is going to be the server's MAC address of FF. And that is the packet been re-encapsulated and turned back into a new frame. So this frame is different from the one that we've seen all along so far. The frame then moves into the physical layer and is then converted into binary bits and sent along towards the server. Now, the server is going to receive the packet. First thing it's going to do, convert it back into a frame so that it can have a look at the information. It's going to want to read the source and destination MAC address. So, converts it back, starts looking at the information. We see that the source came from EE, the local router's interface. Fantastic. We can see that the destination was bound for FF. Hang on a second. That's its MAC address. So maybe we should de-encapsulate. Yeah, that's me. Let's de-encapsulate this. So now we can read the information held within the packet. So we de-encapsulate it, the frame becomes a packet, and we look at the IP address. By cracking open this egg, we can see that the source is 192.168.0.10, the PC. So we know the place where it originally came from. The destination is 10.0.0.10. Wait a second. That's the server. Okay, so that's also me. Let's de-encapsulate it further. So it rips that information off, discards it, and now we're going to look at the segment. So we've de-encapsulated the packet further. It's now become a segment. Now we're going to read the information contained within that. We see that there's a source port of 54321, and then we see that there's a destination port of port 80, which is a web applicator, or it's a web protocol. Server at this point is going to say, what in the actual F? That's the very port that I use. Let's de-encapsulate this further. So it now de-encapsulates, and now the server can actually see the raw data. So the server gets ready to exchange web information. It knows that the PC on the other end wants HTML format, and it's ready to set it up for a browser use. Okay. And that is the entire process, all the way from the PC going through switch, going through router to the end, and any device that it goes through, that same kind of process is going to happen where we're constantly reading the information from one device, and then, you know, after we've read it, do we need to de-encapsulate it further, or can we just re-encapsulate it and send it back on its way? So that's what's going on in these things, and all of this happens in less than a second. Okay, even less than that. So quite frankly, it's a miraculously fast thing that's going on. And if you can understand it now, fantastic. But obviously, once the request got to the server now has to do exactly the same to send all that information back. So we're going to get ready to send the web page to the PC, and it's going to take that raw data, eventually encapsulate it, sends it onto the physical infrastructure, adding the source and destination addresses that all need to be everywhere, until eventually we've just reversed everything, and finally that web page gets received by the PC on the other end. I really hope you enjoyed this one, folks. Again, it's a simplification, but it is a very good overview of what is happening. If you like that, subscribe and stay tuned for more.